And really I should call this reference angles for evaluating trig. Or trig functions, I guess. Okay, for evaluating trig functions. Reference angles for evaluating trig functions. So, the idea is, right, this is, again, our goal is when we see something like sine of 150 degrees, okay, kind of like in the wild, right, we want to be able to evaluate that, okay, and figure out, you know, kind of how to go about, you know, what that ratio is equal to, okay. So we could, you know, look at our unit circle. We could, you know, kind of just always carry this unit circle around with us. We could go to 150 degrees, okay. We know that sine of 150 degrees is the y-coordinate, so we know it's got to be 1/2, a positive 1/2, right? So we know that it's going to equal 1/2. But do we really want to have to remember that unit circle? And for me, the answer is no, okay? I don't like having memorized more than I need to. So the way I like to go about doing these things, anytime I'm doing trigonometry, all right, I like to have some things drawn for myself. So the first thing is I like to draw the two special right triangles. All right, so I'm going to draw the 45, 45, 90. So this is like the memorization part. Okay, and the 45, 45, 90, because there's a lot of different like formulations of it, how you could write it and stuff like that. Okay, the way I like to remember it is this version. Each leg is a length of 1, and then the hypotenuse is the square root of 2. I know the reference triangles we talked about yesterday, the hypotenuse was 1, and each leg was root 2 over 2, root 2 over 2. And you can use that if you prefer. So you could also say hypotenuse is 1, and then each leg is root 2 over 2, root 2 over 2. That will work as well. I just like it this way because there's not so many fractions and stuff like that. Okay. And then likewise, I also draw the the other special right triangle, the 30, 60, 90. So 30 degrees, 60 degrees. So again, this is something that you will have to memorize should you choose to use this method that I'm showing you. These are the two that you'll need to remember. Two things for sure. And then for this triangle, again, we talked about the hypotenuse being 1. In this case, I'm going to say that the side opposite the 30-degree angle is 1, which makes then the hypotenuse twice that, so 2. And then make the other leg the square root of 3 times that. Okay. And so then how do we use this, right? Because again, if you look here, right, these triangles, they don't have 150 degrees in them, right? It's a 45, 45, 90, it's a 30, 60, 90. How are we supposed to do this when we have a 150 degree angle here? Where are we supposed to go? Well, that's where the idea of the reference angle comes in, okay? So, the reference angle it's the angle, or I guess I should say the smallest angle between the like terminal side of the given angle and the x-axis. Okay, so the reference angle is the smallest, whoops, missed a word, smallest angle between the terminal side of the given angle and the x-axis. So what do I mean by that? So 150 degrees, again, thinking, you know, if I just pull this up here in the unit circle, but you won't need this in the future, but 150 degrees, right? If we go from where it started all the way around here to 150, well, that's 150 degrees. But the reference angle is the angle, the shortest angle or the smallest angle needed to go from this terminal side here, where we end up, to the x-axis. Okay, so in other words, it's this angle right here. Okay, it's the closer angle, not the far one, not the 150 that took us the whole way around here from this side of the x-axis. It's the closest angle that it takes us back to the x-axis here. And so what is that angle measure right there? 30. Okay, and so evaluating sine of 150 degrees is very close. In fact, sometimes it's exactly the same, and sometimes it's not. It just is going to change, differ by a sign, okay, whether it's positive or negatives. But evaluating sine of 150 is just like evaluating sine of 30. So, sine of 30 degrees is really what we want to evaluate here, okay? That's what we're going to actually evaluate. How do we do that? Well, there's where our reference triangles come in. We use these reference triangles. We have a reference angle that helps us simplify 150 to a more simple angle, and then we go to our triangles here to then evaluate this. Okay? So, sine, if we remember right from SOHCAHTOA, sine is what over what? Opposite over hypotenuse. So I go to the 30-degree angle here in my reference triangle that I had memorized, that I wrote down, okay, just to help myself out. And I know that sine of 30 degrees is opposite 1 over hypotenuse 2. So it's 1/2. Okay? Now the only other step here that I have to consider is whether, because again, we evaluated sine of 30 degrees here, and we know that's 1/2, but then will sine of 150 be 1/2 as well? Well, we know it is. But we have one other thing we have to keep in mind here, and that is our quadrants. Okay, because different trig ratios are positive or negative in different quadrants. And so again, there's, I guess, a variety of ways to remember this, but in this case, A, for all trig functions are positive in the first quadrant, okay, and then sine and its reciprocal cosecant are positive in the second quadrant. Tangent and its reciprocal cotangent are positive in the third quadrant, and then cosine and its reciprocal secant are positive in the fourth quadrant. Okay. Which makes sense if we think about it, right? Because in the first quadrant, remember, the x and y coordinates are both positive, right? Which means if x is positive, that means that cosine's positive. Remember yesterday we said that x is like cosine, right? And then if y is positive, then our sine values will be positive. So if sine and cosine are positive, tangent's also going to be positive, and so that's why all of our trig ratios there are positive. Here, okay, just the y coordinates will be positive, but the x will be negative, so that's why sine, which is associated with those y coordinates, right? Sine and its reciprocal cosecant will be positive, but then all the other trig ratios will be negative. Here, tangent is positive, and it has to do with the fact that tangent is the same thing as sine divided by cosine. So here, both cosine and sine will be negative because, again, our x values are negative, our y values are negative. So dividing negative by negative will give you positive. That's why tangent is positive there. And finally, cosine is positive in the fourth quadrant because, again, cosine is associated with those x coordinates. The x coordinates are positive, whereas sine is associated with the y coordinates. They're going to be negative there. So that's why we have it written this way. Okay. How you remember it is up to you. Okay. Some people use like the phrase like all students take calculus or something like that. That's how I was taught it. Actually, I learned it X. I went backwards, but that's probably not a good idea to do because it goes 1, 4, 3, 2 instead of 1, 2, 3, 4 like that. So, however you want to remember it, that's what's going to be helpful. So it's these three things that you need to have memorized to use my method of evaluating trig functions. Okay, without a calculator. Okay, so 1, 2, 3. Those three things, and you can evaluate any trig function. So the 150 degrees, we know 150 is going to be in the second quadrant, right? It's greater than 90, but less than 180, so it'll be the second quadrant. Sine is positive in the second quadrant, so this is going to be, in fact, 1/2. And so our final answer there is 1/2. Okay, it's a lot of explanation to do a simple little thing like that, and you might think that's not very efficient, but it's, I think it gets easier with practice here. So let's try another one. Let's do like cosine of 300 degrees, okay? Cosine of 300 degrees. So oh, and by the way, one last thing. On your quiz on Monday, you could have a question just like this. Sine of 150, what is it? And that's what you have to evaluate. You come up with the fact that it's 1/2. Okay? So, all right, cosine of 300. All right, so let's think about this. Cosine of 300, the reference angle for that would be what? What would the reference angle here be? What's going to be the quickest way to get back to the x-axis here? Any ideas? What's the reference angle here? I'll give you a hint. It's either going to be 30, 45, or 60. It's got to be one of those three here to be able to evaluate this way. So, Which one is it? Which one will get us back round? Well, if we go here and look, here's 300 degrees, right? And that's going from here all the way around 300. Or we can go which direction? The other way, and that's just what? What's that reference angle? From here to here. 60. Yeah, it's 60. That's it. Okay, it's 60. That's all. 60. So this is the same thing as evaluating 60 degrees, okay? Because 60 will get us back to the 360, which is on that x-axis. Okay, so cosine of 60 degrees. All right, cosine, right, is what over what? According to SOHCAHTOA, it's adjacent leg over hypotenuse. So here's 60 degrees. Adjacent leg, 1. Hypotenuse, 2. So cosine of 60 is 1/2. So therefore we expect cosine of 300 degrees to be 1/2 as well. Okay. 300 degrees is in the 4th quadrant. It's greater than 270 but less than 360, so it's going to be right in here. Cosines are positive in the 4th quadrant. So cosine of 300 degrees is 1/2. Okay, it is 1/2. Okay, it is 1/2. All right. Let's try another one here. Let's do sine of 3 pi over 4. Okay, 3 pi over 4. Okay, try another one there. So now, when it comes to radians, it's a little bit easier to figure out what the reference angle is going to be. Okay, it's kind of given to you right there. Okay, 3 pi over 4, the reference angle for that, pi over 4. Okay, because we're only pi over 4 away from pi, and so it's the same thing as evaluating pi over 4 here. Okay. When it comes to radians, it's much easier to evaluate those reference angles because it's in the fraction there. If you have like 5 pi over 6, the reference angle is pi over 6. If it's like 5 pi over 3, the reference angle is pi over 3. Okay, so it's a bit easier with radians. So sine of pi over 4. Okay, well we have to remember pi over 4 is the same as what degrees? 45. So we go over to like either of the 45s here, and sine is opposite 1 over hypotenuse root 2. Okay, 1 over root 2, which if we rationalize by multiplying by root 2 over root 2, okay, that's going to give us root 2 over 2. So I mean, it is the same thing, you see. The 1 over root 2 is the same thing as root 2 over 2. This is what we have. Okay. Now, last thing here is sine. What quadrant are we going to be in here for 3 pi over 4? What quadrant is that? 2. Okay, so sine is positive in quadrant 2, so that means our ratio stays positive root 2 over 2. Or 1 over root 2 if you want to leave it that way. Okay. So there it is. Root 2 over 2. Okay, let's try another one here. Let's do, I don't know, cosine of, I don't know, I'll pick one here. 4 pi over 3. Okay. Cosine of 4 pi over 3. What's the reference angle here going to be? Pi over 3, right? Again, with radians, it's easy. You just like eliminate the numerator number. Pi over 3 is the reference angle there. All right, so cosine of 4 pi over 3 is the same thing as, or similar to evaluating just pi over 3. Okay. Pi over 3 is what angle in degrees? 60, so we go to 60 here. Cosine is adjacent 1 over hypotenuse 2, so it's going to be 1/2. And we go up here. What quadrant, though, is 4 pi over 3 in? The third one. Now, in this one, tangent and cotangent are the only positive ones here. So cosine of 4 pi over 3 should be negative 1/2. And that's our answer. Okay, that's our answer. Okay. So let's see here. How about you guys? I'm going to have you guys try some then. Let me see if I've got enough here to pick from. Yeah, okay. So I'll just pick some out here. So why don't you all try sine of 315 degrees cosine of pi over 3, and then cosine of 7 pi over 6. Alright, so evaluate those three. Give those three a try. Okay, and try not to just look at your unit circle. Try to use this method here that I was showing you. Identify that reference angle. Evaluate it at the reference angle using those reference triangles. Okay. And then make sure you have the right sign. Is it going to be positive? Is it going to be negative? Okay. Third quadrant, so only tangent. And that's right. I'll point out is 315 is in the fourth quadrant, and this is in the third quadrant, so watch your signs here too. Like FNGN signs, whether they're positive or negative. So that should be negative. That's the third quadrant there. Yes. Yeah, sorry, 7 pi over 6. That's my handwriting right here. Yes. Right. Yes, because the idea is, the way I'm telling you to do it, you'll end up with this, with 1 over the square root of 2, right? But if you rationalize that, root 2 times root 2 is just 2, and then, so 1 over root 2 is root 2 over 2. Okay, that's all. Alright, so we should have gotten negative root 2 over 2, 1/2, and then that's a negative root 3 over 2. Negative root 3 over 2. Okay. If you put negative 1 over root 2 for the first one, that's okay, that's fine. But negative root 2 over 2 there is what I'm going to be putting. Okay. So, there's that. Any questions on any of that? Alright, so hopefully we're feeling a little bit more comfortable with that. So now that we're feeling comfortable, I'm going to make us a little more uncomfortable now, because what about something like sine of pi over 2? Pi over 2, we don't really use this method, okay? When it comes to like the pi over 2, the 3 pi over 2, pi, and 2 pi, which we do need to be able to evaluate those, okay? We don't really, this method doesn't work because it's 90 degrees, and these reference triangles don't really work for the 90 degrees, right? So, how do we do this? Well, this is where you do kind of want to be familiar, right? Okay, so pi over 2, that's at that 90 degree on the unit circle, right? If you think about your unit circle, okay, that's this point right here on the unit circle. And so the coordinates for that point are the coordinates 0, 1, right? Because it's a radius of 1 on that unit circle. And so then the sine of pi over 2, sine is the y coordinate, so it's just going to equal 1. Okay? And that's it. There's no reference triangle for that. So again, for sine of pi over 2, or like cosine of 0, we need to be able to know what that is. Okay, so again, 0 degrees, right? That's like here on the unit circle, right, which has coordinates 1, 0. Cosine is the x coordinate, so cosine of 0 is just going to be 1. Okay. We need to know sine of 3 pi over 2. Okay, 3 pi over 2, that's here on the unit circle. Right, so it's like going around to here. Well, we know the coordinate there is 0, negative 1, and so therefore sine of 3 pi over 2 is going to be what? Negative 1, because the y coordinate at that point is negative 1. Okay, so unfortunately this method doesn't work for everything. Okay, unfortunately this method does not work for everything. Okay, you do still need to be familiar with your positions at 0, pi over 2, pi, 3 pi over 2, and then 2 pi as well. 2 pi is the same thing as 0, right? So that's the one kind of catch here, okay, which maybe there's lots of catches you feel like, but that's the one catch. But this is how, again, this is how kind of I feel like is the most kind of procedural way to go through it, or something that's going to kind of help you at least organize your thoughts about how to evaluate these. I'll tell you now, the way I evaluate these things is I kind of mentally picture where we are on the unit circle, and then I just come up with the coordinates. It's not the same, but that's because I've been doing this for a lot longer than you guys have. This is where I started out, and it worked for me, and so hopefully it'll work for you. Okay? I mean, I'm not gonna lie. You know, at the start of every pre-cal test, like our trig test or whatever, I would just start with writing note after my name. I would draw the reference triangles at the top, and maybe even draw like little, ACTS or all students take calculus thing. I draw that too. It might be helpful to, again, even on our like timed trig quiz on Monday. You could like start by write your name and then or draw on these things at the top of your paper when you flip your paper over, just so you can go back and refer to them real quick. It's up to you, but that's again the best way I can come up with. So hopefully that helps. Okay. Let's see here. So of course that's sine, cosine, or sine and cosine, but we have other trig ratios we have to worry about too, or think about, right? So for example, what about tangent, for example? So evaluating tangent, cotangent, cosecant, and secant. Okay? You're like, oh, we've only done 2 trig ratios, we have 4 more we got to talk about. The good news is, though, if you know sine and cosine, you can do any of the other 4. Okay? All these other 4 are derived from sine and cosine, or a combination of them. So you don't need to know everything, you just need to know sine and cosine. Okay? So, and I kind of want to keep my reference triangles there, but okay, we'll see. So to do tangent, for example, the key thing to remember about tangent of theta is that it is equal to the sine of theta divided by the cosine of theta. Okay? Which means then that the cotangent of theta, whoops, bless you. Okay? Cotangent of theta is equal to what combination of sine and cosine? If tangent is sine over cosine, what's cotangent going to be? Cosine over sine. Yeah, they're reciprocal. Okay. Other key things to remember. Cosecant of theta is merely 1 over what trig ratio? Sine. Yeah. And secant of theta is 1 over cosine. So why we start with sine and cosine, why we bother with sine and cosine on our unit circle, why we ignore tangent, cotangent, cosecant, and secant, because all 4, tangent, cotangent, cosecant, and secant, can be rewritten in terms of sine and cosine. So if we know sine and cosine, we know tangent, we know cotangent, we know cosecant, we know secant. That's the purpose. So if I throw something at you like the tangent of 30 degrees, you don't have to have tangent of 30 degrees memorized. You can remember that tangent of 30 degrees is the same thing as sine of 30 degrees over the cosine of 30 degrees. Okay? And then you can go back to your reference triangles here. So let's see. Sine of 30 degrees. Oh, actually, shoot, what am I doing here? Never mind. Well, I'll come back to that. Never mind. Okay, I'll come back to that. So we can do it this way. Sine of 30 degrees, okay, is opposite 1 over hypotenuse 2, so 1/2, over cosine of 30 degrees. All right, cosine is adjacent root 3 over 2 over hypotenuse 2. Okay. Which dividing by a fraction is the same thing as multiplying by its reciprocal. Okay, so dividing by square root of 3 over 2 is the same thing as multiplying by 2 over square root of 3. The 2's simplify and cancel out, and we're left with 1 over the square root of 3, or if you rationalize, it's root 3 over 3. Whoops. Root 3 over 3. Okay. So there's tangent. Okay. But there's an easier way than that. Okay. So that's one way to do tangent. Remember, it's sine over cosine. But there's an easier way. And I can't believe I slipped my mind there. Tangent of 30, tangent we know is opposite over adjacent, right? From SOHCAHTOA. So tangent of 30, opposite of 30 is 1, adjacent leg is root 3. And so you can literally just use the reference triangle there for 1 over root 3, which is the same thing as root 3 over 3. Okay. So you can also just use the reference triangle. TOA, opposite over adjacent leg. You don't need to do the sine over the cosine stuff. But it is the same, just so you can see that there. Okay. So we'll do another one here. Let's do, I don't know, tangent of 60 degrees. And I'll also do tangent of 45. Let's just do both. It's so easy with our reference triangles here. Okay. So tangent of 60 degrees. Well, let's see here. There's 60, right? Tangent is opposite. Root 3 over adjacent, 1. So it's square root of 3 over 1. Or just square root of 3. Okay. Tangent of 45. All right, so here's 45. Tangent is opposite 1 over adjacent 1. Tangent of 45 is 1. Okay. Just use those trig ratios there. And the reference triangles. Okay. I want to look at one more here. Let's say like tangent of pi over 2. Okay, just throw this one at you here. Okay. Tangent of pi over 2, right? That's pi over 2, remember, is 90 degrees. That's one of those angles that's not in our reference triangles. We can't use our reference triangles when it comes to like the 0, the 90, the 180, the 360. You can't, or 270 and 360. You can't use it. So how do we evaluate these? Well, here you do want to go back to that sine over cosine. Tangent of pi over 2 is the same thing as sine of pi over 2 over cosine of pi over 2. Okay, because again, you can't use a reference triangle. We don't have pi over 2. We do have the 90 degrees, but it doesn't work using those reference triangles. So you have to use the kind of unit symbol. Okay. What's the sine of pi over 2? 1, good. What's the cosine of pi over 2? 0. Tangent of pi over 2 is undefined. Okay, undefined. 1 over 0, undefined. And sure enough, if you type tangent of pi over 2 into your calculator, when you're in radian mode, it gives you tangent of pi over 2, error, domain, because pi over 2 is not in the domain. It's undefined there. Okay. Which means then, right, that we can also do other things like secant. So let's do like secant of, I don't know, pi over 6, and then we'll try like cosecant of like pi over 3, and then we'll do like cotangent of, I don't know, 5 pi over 6 or something like that. We'll just go crazy here. Just throw in some other ones. Okay? So So secant pi over 6. Okay, again, you can remember there's two different ways. If you want to remember like Choshikow, you can remember Choshikow, okay? So Chosha, it's like secant is hypotenuse over adjacent. Okay, so you can remember it that way if you want to. So pi over 6 is 30 degrees. Hypotenuse is 2 over adjacent leg root 3, right? So 2 over root 3, which if we rationalize that would be 2 root 3 over 3. Okay. Alternatively, you can remember that secant is the reciprocal of what trig function? Cosine. So if you do cosine of pi over 6, so cosine of 30, that's going to be adjacent root 3 over 2, so you just then flip it 2 over root 3. You can do it that way too. Okay. So cosine of this would be root 3 over 2, root 3 over 2, and then you just flip it then 2 over root 3 to get the secant. Okay. Same thing with cosecant, right? You can use Choshikow, so C-H-O. Cosecant is hypotenuse over opposite. Oops, we're on pi over 3. So pi over 3, hypotenuse 2 over opposite root 3, so it's going to be the same thing. 2 over root 3 there, which is then 2 root 3 over 3 when you rationalize it. Okay. And then cotangent 5 pi over 6. Ooh, 5 pi over 6 is not up here, but what's the reference angle for 5 pi over 6? Pi over 6, or 30 degrees. So we use our 30 degree angle here. Okay, cotangent, so Choshikow, that's the, I can see how why Choshikow is not good, because you have two C's. But anyway, second C is the second C, cow, C-A-O. So cotangent is adjacent over opposite, so root 3 over 1. Again, you can think of it in terms of tangent. Tangent of 30 would be 1 over root 3, and then just flip it. We have to watch out here, though, too, because what quadrant are we in with 5 pi over 6? 5 pi over 6 is not quite pi, so we're not quite at 180. What quadrant would that be? 2, and cotangent is positive or negative in quadrant 2. It's going to be negative. Okay, it's going to be negative. Okay, it would be negative. Okay. So, we'll stop there, I think. Okay. Any questions on any of that? Hopefully, that I think it'll become more comfortable with practice. With practice, yes, with practice. So we're going to do some practice right now. Get you guys your assignment. Okay. So again, on Monday, you will not be responsible for these 4 trig functions, only sine and cosine. All right, and only in the first or second quadrant. Only in the first or second quadrant. Okay, so get you guys the assignment here. Alright, your work is going to be page 316, numbers 19, 21, 37 to 43, 59 to 67, and then 85, 89, and all of these are odds, just odds. Okay, so 37, 39, 41, 43, 59, 61, 63, 65, 67. You get that? Okay.